As we all know, both renewable and non-renewable resources have been used by humans to meet their energy needs. They undoubtedly have their drawbacks, which now include climate change. The greatest existential crisis in human history is currently upon us. This won't be an issue anymore, though, as scientists have finally figured out how to produce vast quantities of renewable energy, just like nature has been doing for billions of years. Finally, nuclear fusion on Earth has been successfully produced by scientists. Join me as we explore the fascinating and revolutionary news of how scientists make it possible in more detail as to when we will be able to see it. And what makes it revolutionary? To begin with, what exactly is nuclear fusion and how does it generate electricity? Nuclear power facilities that use the nuclear fission concept are presumably familiar to you. Both nuclear fission and nuclear fusion alter nuclei, the dense centers of atoms consisting of protons and neutrons. A big nucleus is split into several smaller nuclei during the fission process, releasing a significant quantity of energy that can be used to generate electricity. An element with a larger nucleus is uranium, which can be divided into elements with smaller nuclei like krypton and barium. This produces a significant amount of radioactive waste that must be disposed of correctly and safely. Nuclear fusion, which is the reverse of nuclear fission, entails fusing too many smaller nuclei together to form a larger one, which releases energy once more. The Sun uses fusion to generate energy during the process. To produce the helium that keeps life on Earth possible, 620 million tons of hydrogen must be burned every second. Theoretically, by repeating this procedure, enormous amounts of energy may be released and used to power our lives. However, in reality, things are a little more complicated than that. Energy is necessary for both fission and fusion to begin. To justify spending money to trigger a response, you must receive more energy out than you put in. This notion, however, is irrational on its own since you cannot produce energy, rather, you can only move it from one form to another. It is possible to employ the idea of mass-energy equivalence, which simply states that every object having a mass also has intrinsic energy. Einstein's famous equation E equals mc squared, in which E stands for energy, m for mass and c squared for the square of the speed of light, is used to explain this. Therefore, whether dealing with fission or fusion, energy is always conserved. The fact that some atomic mass is converted to energy and released during fusion can be utilized to power electrical generators. Nuclear fusion is the ideal form of energy. It is clean because, unlike fission, it does not immediately generate radioactive waste. Although some radioactive waste does result from reaction products reacting with the reactor's construction components. Even though fission is currently the most efficient way to generate electricity, fusion has the potential to release up to 4 times as much energy. According to calculations, a few grams of raw materials might generate enough energy to sustain one person in a wealthy country for more than 60 years. The most sought-after free energy source, nuclear fusion, powers the Sun, one of the planet's most significant energy sources, as we are all aware. In the English village of Coam, close to Oxford, researchers working on a massive tokamak reported that they had generated and sustained nuclear fusion on February 9, 2022. A record-breaking 59 megajoules of sustained energy fusion were produced by scientists at the Joint European Torus, also known as the JET tokamak, over the course of 5 seconds. The gadget can only maintain power for a maximum of 5 seconds before its magnets become too hot on December 21 of the previous year. This was more than twice the amount of their earlier studies from 1997. The process consumed more energy than it generated and there was hardly enough to power a dwelling for a day. Nevertheless, it was a significant event. It has been established that nuclear fusion is feasible on Earth. The challenge is, how do we extend it beyond, say 5 seconds, and why is it so agonizingly challenging to do in our daily lives as energy is needed for a variety of tasks? Both the production of electricity for our homes and space exploration depends heavily on nuclear power. There are currently 439 nuclear power stations in operation worldwide, with the United States having the most, 96. The creation of sustained fusion reactions on Earth has long been a goal of science. The intense conditions make it difficult to produce and maintain fusion. The International Thermonuclear Experimental Reactor, or ITER for short, was built by 35 nations as a result of their collaboration to enable nuclear fusion. The news from England, however, was excellent for the project in France. The reactor will be the pioneer of nuclear fusion and the biggest device of its kind ever constructed. The primary goal of the project is to demonstrate the viability of commercial fusion. The experimental fusion plant will have a core that is 10 times hotter than the Sun while it is operating, and magnets that are as cold as interstellar space will surround it. ITER's purpose is to fuse hydrogen atoms and generate enormous amounts of heat using superconducting magnets. The neutron's kinetic energy is converted to heat when they strike a blanket that lines the tokamak's walls after managing to leave the plasma. The water can then be heated to produce steam, which can subsequently be used to power turbines. Conventional hydrogen atoms with proton-only nuclei won't be used in the experimental reactor. Deuterium and tritium will be fused together instead. While tritium is scarce but can be produced inside the fusion reactor if the supply of these fuels is sufficient for millions of years, deuterium is easily collected from seawater. When the first portion of the ITER plasma chamber was safely taken out of tooling and put into the machine on May 11, the ITER project reached a significant assembly milestone. Well, the late ITER Director General, who supported fusion energy, spoke highly of it. He passed away on May 14. When there were fewer than 1 billion people on the planet, Bigots asserted that there were sufficient renewable resources to supply demand. Since the Industrial Revolution and the subsequent population growth, he claimed, not anymore. There is no choice but to wean ourselves off our current main power source, and the best option seems to be the one the universe has been using for billions of years. This is because we embraced fossil fuels and caused significant environmental damage, and now that we are 8 billion strong and in the middle of a dramatic climate crisis, there is no other option. For times as much energy as nuclear fission is generated by fusion, which is an extremely powerful process. If fusion energy can be successfully developed, it will likely power the majority of the Earth. For the same amount of energy as 8 tons of oil, just 1 gram of fuel is needed. Certain issues do exist. It's not making fusion energy that's challenging, according to some researchers. Since the invention of the hydrogen bomb, people have been performing nuclear fusion reactions. Maintaining them is the main difficulty. Thus, if this research is successful, the goal will not be to just use the energy for power generation but rather to demonstrate that it can sustain fusion energy for a considerable amount longer than usual. The hydrogen isotope tritium, of which there are currently only 20 kilos in existence and only 400 grams are required annually with a price tag of $30,000 per gram, presents another difficulty for ITER. If it becomes popular, the need for nuclear fusion will increase, posing another challenge to fusion scientists worldwide. However, the issue doesn't stop there. From a distance, it could look like a finished job, but up close, it's clear that it's still a way off. The project is very challenging and spans 39 building sites. The tokamak's shell has been finished, but vital parts, such as a sizable magnet from Russia, are still in transit. The tokamak will weigh 23,000 tons when it is finished. That is the combined weight of the 3 Eiffel Towers. It will be composed of 1 million pieces, each divided into 10 million smaller parts. The digital design is split up into numerous 3D computer files that take up more than 2 terabytes of storage. The situation in Ukraine also poses a threat to ITER, which is run by 7 key members: China, the United States, the European Union, Russia, India, Japan, and South Korea. Concerns exist over both this potential exclusion as well as Russia's continued participation in ITER. But if the experiment is successful, according to international scientists, fusion ambitions might begin to materialize as early as 2040, with a 2-gigawatt fusion plant constructed to endure at least 60 years. This will bring an end to the current turmoil and be a revolution. What are your thoughts on ITER?